Hello, everyone. I'm gonna give people like 3 more minutes and then we will start. Actually, one thing we can do while we're waiting for people, I'm gonna launch a poll and see if you guys are able to see it. Oh, crap. Oh, cool, it didn't work. Ay. Okay, that's annoying.
I don't think I have the ability to do that.
To do what?
To launch a poll.
Oh, I can launch a poll, but I saved the poll questions and responses earlier, and that did not spawn over to this. Okay. I launched a poll. If you don't mind responding to it, that's great. And they're all anonymous. So, mm, I'm realizing that they're mutually exclusive, and for number two, you might have multiple. So I apologize for that. I didn't realize this poll was skewed in that way. I guess you can identify the one that's most appropriate. Okay. We've got one non-participant, but that's okay. If you want to put in your last bit. Okay. Sorry, I'm just trying to share it in our slides. That's going to be a little bit funky. Okay. Mm, okay. Thank you for your patience. I appreciate it. Let's see if I can start my video also. Hi. um, Thank you for joining. I apologize about the split where my voice is coming from a different terminal. Is that okay for people who might be using assistive tech and otherwise? Okay, if anyone's having accessibility issues, let me know. I should tell you that I'm having a hard time seeing the chat while everything else is going on. So, Cole, if you don't mind monitoring things, that would be
Yep,
great.
sure.
Thank you. So, sorry.
Just clear my throat. Sorry.
Okay. All right. For those of you who are comfortable, I invite you to turn on your cameras. And my name is Anat Caspi. I'm the director of the Tasker Center for Accessible Technology, which you see there. We are part of the Paul G. Allen School for Computer Science and Engineering, and we're also part of eScience. And this class is about responsible data science. And in particular, we're going to focus on data science in urban settings. And as you learned today, the way we will explore responsible or ethical data science will be specifically through a lens on disability and non-ableism. But that's really just a way to instantiate and give us a really palpable idea of what it means to like explore ethical issues in the realm of data science. So I often use that as an example. It's a lot less polarizing than, say, non-racism or gender biases, but it's a really great way to better understand, disparities and inequities that are created by data science. And I think in general, I work a lot in disability activism, as well as trying to explore non-ableism in everyday life and technologies. So I think it's a good way for us to talk about data science and how we can improve quality of life as well as independence for everybody by looking at ableism as a biasing force in data science, and particularly as it pertains to urban planning and transportation planning. So I'll be presenting this first part of our session. Also joining us today on camera is Cole Anderson. Cole, do you want to introduce yourself?
Yeah, I can take a minute to do that. So my name's Cole. I'm going to be kind of handling the more GIS software portion of this course, but I'm a Master's of Geographic Information Science, and I have been working at the Tasker Center, working on some of their accessibility projects for about 6 months now. Enjoying the work I've gotten to do, and this is my second time, or kind of our second time teaching this course, and I'm really looking forward to it. And so hopefully we'll have some time to getting started with our software program today as well.
Yeah. I'm wondering, I wasn't totally planning on doing this because we have a lot of content to go through, but I think it makes sense in like this size of a group to maybe go around and introduce just people, how quickly say who they are, what they're studying, and why they're interested in this course. That would be great. So I'll stop my sharing so everyone can do that. All right, I will popcorn to Jolie. Yeah. Oh, okay. Do you want us to come back to you? There you are.
Okay.
Yeah.
Okay. So hi, I'm Jolie, and I'm currently studying geography data science. This is my senior year. So and I'm really excited to join this because I'm currently working on some assess sidewalk data with OpenStreetMaps, and I think it's gonna be interesting to incorporate some kind of responsible data science through this project.
Thank you. Do you want to popcorn to somebody else?
Yeah, I'll popcorn it to Jaden.
Alrighty. Hi, everyone. I'm not going to talk super loud since I'm in Marriott Hall at the moment. Yeah, my name's Jaden. My major is in geography with a concentration in data science. I'm just excited to be learning about different types of data that we're going to be working in this class, because it's kind of a blend of a lot of things I've been studying, because I'm also a minor in urban planning. So yeah. I'll popcorn it to, let's go to Wendy.
Thank you. Hi, I'm Wendy. I'm also a senior in geography data science major. I don't have any experience with a real large project with the data science, so I'm really excited to join this project group. And I know this is gonna be a little bit challenge for me, but I'm excited to see what skills I can learn. I'll popcorn this to Aileen.
everyone. My name is Ian and I use sugar pronouns for intending to study informatics and geography data science. And I joined this class because I am super passionate about equitable urban planning and I'm excited to work with municipal data science. And I will pass it to Sabrina.
Hi, I'm Sabrina. I use she, her pronouns. I'm a senior studying informatics and also the geography data science concentration. I'm taking this class because I feel like it really lines up with what I want to do in graduate school as a senior moving forward. And it seems like the natural build-off point for a lot of the research projects I've engaged in up until this point with Seattle City Light data and taking urban planning classes outside of my own majors. So yeah, I'm really excited to be here. I owe popcorn to Alex.
Hello, I'm Alex. I use he, him pronouns. I'm a senior in the geography data science major. And I'm really excited about this course because I'm really passionate about equitable urban spaces and how we can use data science, particularly GIS, to achieve that. Jackie?
Hi, my name's Jackie. I'm currently a senior majoring in informatics and I'm planning on minoring in data science. And I got interested in joining this class because I have like some minor interests in like landscape architecture and like urban planning. So I want to see how my two interests can fit and come together into a project. I haven't had much experience with data projects outside of like class projects, so I'm excited to have a real project. So, Mohammed, have you on?
Yeah, here.
Okay.
My name is Mohammed, and I'm a junior in informatics. I'm excited to take this course since I've only learned a little bit of data science and I've never taken anything about GIS, and so it's something that I was interested in. All right, popcorn to Mo.
Hey guys, my name is Mo. I'm a sophomore in informatics. I was interested in about this class because I've heard about JS, but I never used it. So I was pretty interested in learning a new skill. That's why I joined this class. Next up is Myelina.
Lorena, are you there? All right, we'll go to Kohei.
Hi, I'm Kohei. I'm an exchange student from Japan, and I studied my major is computer science in my own university. And yeah, I belong to the hand sign languages club in my university, and I'm really interested in communicate with the people with disabilities. So that is why I chose this class, and I'm really excited. Thank you. Oh, Christy.
Hey everyone, I'm Christy. I don't go to UW, I go to UC Berkeley and I am a junior majoring in data science and computer science. And I guess I took this class because I've never interacted with like GIS, so I wanted a chance to work on that for this project. I'll pop it off to Rishi.
Hi everyone, my name's Arushi. I'm a sophomore in the informatics program. I opted for this course because I'm really interested in social responsibility and data science. So I kind of wanted to see like the intersection of that in urban spaces. I've never really done a data science project before, so I'm really excited to work on all this with you guys. And I'll popcorn it over to, has Jolie gone yet?
I did.
Yes, but Reina, who appears on my top line, hasn't yet.
Yeah, I can go. Hi, my name is Reina. I use she, her pronouns. I'm a senior in the informatics program. My minor and concentration are both in data science. And I'm really interested in public transit and how it relates to disability rights. So I'm really excited to work on a project that'll kind of incorporate all those skills and interests. And I will pass it off to Hao Chen.
Hi, good morning, guys. My name is sorry. Sorry. Um, can you guys hear me well?
Yes, thank
Cool,
you.
cool. Hey guys, my name is Hao Chen. I'm currently a senior studying geography data science. I'm joining this class because I've been having projects involved with data science before, and I really want my projects to extend to some like social impact, that kind of perspective. And that's why I really want to join this class, just to meet some like-minded people and start collaborating with some projects together. Um, who hasn't gone yet?
I think we've got Aaliyah.
Oh,
Yeah.
I pass it to Aliyah.
Hi everyone, I'm Alia and I'm a senior in informatics. I'm taking this course because I'm passionate about data science and I thought it would be a great opportunity to like develop my skills and also like use them to address real problems in the world. And also it'd be cool to explore GIS. I've never done that before. So.
I think we got everyone. Milena reports that her microphone is not working and she's a senior majoring in geography, interested in the use of GIS and data science in urban planning. Aside from her, did we hear from everybody? I just want to make sure.
That's everybody on my list that seems to be here, so.
Fantastic. All right. Okay, thank you, everybody. That was great. I'm glad to learn more about you as time proceeds. So our hope here is to explore how data science can be made inclusive of both practitioners as well as data consumers of all abilities. And oh gosh, that didn't work out so well. So who's in the room is the question that's asked here. And these were our responses here. So out of the 16 respondents that we had 12 who have said they practice data science in their educational careers, and 4 who described having a sense of what data science is, but not practice it themselves. And then for the second question having to do with relationship to disability, 5 out of the 16 respondents indicated that they live with a disability. 2 said they have a personal relationship with a person with a disability. 7 out of 16 said they don't have much of a direct relationship. And 2 out of 16 work on issues of disability on a professional or volunteer basis. And I assume that, like I said before, these are not mutually exclusive, but people just chose the ones they feel the greatest affinity to. And I'm sure if we had multiple choices here, it would look a little bit different. I know I struggled to pick the one that I align with best. So today's flow is just to have a 20-minute introduction, like what is our purpose here, and then 20 minutes on what adopting a specific ethical lens in data science might be, and specifically then what is a disability justice lens lean us into. We'll take a tiny break and then we'll break it down via cards. And I do want to leave room for Cole's presentation. I do, if you don't mind, can you raise your hands if you were able to download and install QGIS? I know you got very short notice, so.
Yeah, and I apologize about that. If we don't get to it today, I will just share the slides with you. The first lecture is pretty much just getting started with the interface for QGIS, so it's not super complicated, but if we don't get to it, that's okay. I'll make sure you get the material either way.
It looks like most people actually did, so that's good.
Oh, well, it doesn't take that long to download, so that's good.
Well, but if you don't have the dependencies, then it's an issue. So
well, if you downloaded it that way.
Yeah.
Anyway, we'll deal with my stuff if and when we get to it, and if not, then I have plan B. So
cool. All right, thank you. So our basic premise here is that data science is increasingly important in producing knowledge and technologies that impact our daily lives, and how it is that we analyze data, design analysis tools, deploy algorithmic systems, as well as publish the data-driven conclusions from it really matter to real lives. And when data science ignores the variations and disparities in the human experience, it can bias that decision-making processes or the outcomes that come out of the data science artifacts, and those can negatively impact people in general, and also negatively impact people with disabilities. So one example is that there are a number, I'm just talking about higher view here, but there are actually a number of software systems out on the market that are intended to provide would-be employers ranking tools to assess job applicants and potential employees. And last year, the Department of Justice issued a specific guidance for employers on how to use AI-based tools to do those assessments, because it was recognized that both voice recognition as well as face recognition software, if it's not, from the get-go, from the planning stages, used in a way to be inclusive, it could potentially provide certain biases. Does anybody want to sort of ideate on what are some potential biases that may occur when you're doing, using voice and face recognition to assess a candidate for a job application? Sabrina?
Definitely like gender, for example. Yeah, if most of, sorry, my cat just knocked over something. But for example, if it's training on data that has mostly male applicant voices speaking because your company is made out of mostly men, then any graded lower, no matter. I guess a more feminine voice would be great.
Right. So in some way, these data science algorithms, the models are trained on a specific data, whatever it's fed, and that ends up greatly impacting what models are learned using those training data. So if your training data is not representative of different potential components of the population, not necessarily reflective of what is currently there, right? Because as Sabrina said, your current employee composition may be biased, and so you will just perpetuate that bias by training on their data. I think I may have seen another hand up. Did I miss somebody? Okay, cool. So, we talk about data science, but we haven't defined it. And there are many definitions out there. And so I don't pretend to hold the one right definition. Let's just make an agreement here to have certain aspects of data science that we agree on are a part and parcel of the work that goes into data science. So we're not going to define AI or define data science, but in our conversations, we'll refer to data science as the practice of deploying computational and typically statistical methods to derive patterns, elicit insights, or make some predictions through the use of data sets, and typically large data sets. Does anybody have an objection before we unpack this? Yeah. Any objections? Did I? Okay. And of course, it's missing nuances to what happens in data science and AI, but that's kind of the large umbrella that we will try to address. And we talk about computational algorithms or processes. We're talking about working in complex and semi-autonomous ways. So to frame our conversations a little bit more tightly than what was previously said, you know, we want to look at more complex and semi-autonomous algorithms that might make some inferences or decisions. We're talking about systems that derive patterns or elicit insights or make some predictions from data. And we're talking about pattern insights or predictions that are used as evidence for some unobserved event or phenomena or to motivate some kind of action, right? So what is the action we're trying to, we would presumably motivate with higher view? Anyone? What kind of trigger is that trying to elicit? Sabrina, you unmuted, but I don't know if that's still from before.
Oh, sorry, that's from before.
Okay, do you want to answer? What is higher view trying to trigger or motivate an action for people?
Sorry, repeat that, please.
What's that?
Sorry, I can't really hear you. My audio is cutting out.
Oh. All right, anybody else? Or you can put it in chat. Wait, maybe there is something in chat. I saw something. Okay.
Not for that.
Got it. All right. So what is trying to trigger or motivate there is like develop trust for a particular employee, potentially invite them to an interview because they are seen as skilled. So that would motivate the action of like bringing them back for an in-person interview or something like that, right? So the other thing we want to question is like, are we producing knowledge and technologies that impact daily, right? Because we said that in the earlier definition. And what we're talking about here is data science having a direct output of a process, a protocol, or a data science pipeline. And so as part of these activities, we are planning data experiments, we collect data, we analyze data, we design analysis or analytic tools, we learn data models, we verify and then validate those models, we deploy algorithmic systems. So like there's a lot of different steps that are embedded in this activity we call data science, right? So all of you that are trained in data science have at least done some portions of these pipelines, right? Of these parts of the pipeline that are described here, along with, you know, finally having some kind of inference or a data-driven prediction or conclusion. And so each one of those components can be open to potential biases, and that's where we're going to start our work on understanding the ethics of doing these different steps in the pipeline. And finally, when data science ignores variations and disparities in the human experience, we can bias that decision making or the outcomes, and then that can negatively impact people, and specifically people who have inequities in society. So how do we talk about process bias is what we're trying to do in this class, right? So we need to take it with a particular critical lens to examine these processes that produce the data science products, like all those different things we named in the previous slide. And of course, we aspire to like distill and automate reasoning and judgment that is aligned with what we might consider like intelligent human-like data science outputs. Many algorithms and models used in data science are really just very simple algorithms, and they are imperfect models, and they are, I would say, under defined models because you only have so many variables, and they are therefore susceptible to making some erroneous assumptions. So that's kind of like framing our conversation here. Does anybody want to respond to that before I move forward? Any objections? Which is totally fine. Oh, I think I just saw a chat about too much pressure on appearance. Jolie, was that in response to what is the the higher view trying to motivate or trigger?
Yep.
So yeah, it's taking a certain, the only data inputs it's getting is a voice feed and a video feed, and it's trying to glean from that some essential important features of this person, and so that might be having a biasing impact. I think someone is muted. Thank you. Okay. All right. So when we start talking about systemic biases in data science, I want to give you like real palpable examples of how we can take a critical lens and talk about data science from a particular framing, right? Like if we just say, oh, this is biased, it doesn't give you the sense of like, how is there an interplay between real life systems and how that might impact the outcomes of data science products? So let's talk about ableism as one potential biasing system. And one definition for ableism is systemic biases that privilege individuals who fall within a certain range of what's called non-disabled, right? So a lot of times we use statistics in ever since, for example, the public school system came into being, there have been these bell curves or Gaussian curves fitted to humans. And the idea around that is to say, okay, everybody standard deviations from the mean are considered norm. And anybody outside of that is outside of our norm. And we will put them in this category of like, outside the norm on whatever axis we're looking at. So whether it be eyesight or whether it be hearing or whether it be what are some other axes, height and weight, like it's not, doesn't all have to do with abilities necessarily, but of course that ends up playing a role when we're looking at norming people. And so ableism is at its highest a set of primary social and political structures that end up marginalizing, organizing, and ranking subjects and objects, and they shape the way we discuss, what is normal. And it also undergirds many of our institutions, right? Because many people who get tested for eyesight, or tested for hearing, or tested for mobility end up, sometimes falling just below, just within the two standards of deviation or just above it. And that ends up really shaping their experience with those institutions. Does anybody have any other examples other than schooling where this plays a role? And I'm opening this up to anyone pretty much.
Can I go?
Yeah.
Yeah, so I would say, for example, Google Maps. And we use Google Maps to kind of commute from one place to another. So if you're walking, you commute from one place to another, and then it always gives you like the shortest path. It works for us as a able, non-disabled people. But what if you're in a wheelchair and you cannot kind of like go on the middle of the road without the help of curb ramps? I think that is also systematic bias.
In that system. So I see your point. I think the biggest issue with Google Maps is that they don't have data to represent those requirements. And of course, the assumption is that everybody can just use any street that's marked as a road, right? And I guess the question is how there's no cutoff there per se with respect to they just they have whatever data they have, and then they pretend as if that's a sufficient amount of information for everybody. But really it's not as if they made an artificial threshold or cutoff. Like more of my thought process is around for instance, in the medical system, like when they consider newborn babies failure to thrive, it's like a very tight line where they decide, you know, and different governments might make that decision on where that cutoff is very different, but they will then like offshoot those newborns in a particular direction of like starting medications and giving them different feeds and, you know, things like that, which really it's really about more of a continuum, right? It's not as if like that artificial cutoff that someone decided on, which is like, oh, okay, if they gained 5 pounds in their first 2 weeks, then they're doing great. And if they gained 4.999 pounds, they're not, right? Like, but many of our institutions create these artificial kind of cutoffs and protocols, and that really ends up structuring and marginalizing certain people, sometimes on a pretty arbitrary threshold biases. So that was more of what I was talking about. I think what you're talking about is also very pertinent to this conversation. But in that case, it's more of, I think, an honesty about like what data Google is purveying, right? They're making the pretense that giving us road information to everybody is good data about where to walk, where, you know, I may not exhibit like a motor limitation, but you don't want to stick me in the middle of the street. I don't feel comfortable or safe, and I'm not going to walk there, right? Like, and the information that they provide is just uniformly bad for everybody, just based on the fact that they're not being truly honest with what information they're conveying to people when they say pedestrian routing, right? But I think we'll talk about that in a little bit. I'm looking at the time, so I will finish the discussion of the framing and we'll do the cards next time so that Cole gets a little bit of time as well. So what is then, if we talk about ableism in this way, then how can we analyze disability not just as a structural and institutional barrier, but also from the framing of like, are we culturally, historically, economically, socially, and politically biased as well? And of course, some people will say yes, and others will say, well, that just comes with like having these institutional hurdles that you're biased into. So what I'm trying to convey here is that even within the framing of ableism and disability justice, there's a broad spectrum of what you might look into to understand how is this biasing our data science processes and the processes we undertake in order to produce these technological artifacts. So that's a big mouthful and a big framing. I am happy to take any questions at this point. Any big or little questions? So I'll skip describing exactly what disability justice is, but we do want to emphasize some of, oh, sorry, Arushi, did you have a question or comment?
No, I was just turning my camera.
Okay. So if we take just a generic critical stance, right, we want to emphasize that social constructions of whether it be ability, race, gender, allows us to also recognize the material and also psychological impacts of being labeled as one thing or another, as a member of a specific gender, as a member of the disability community, as a member of a certain race or ethnicity. And that could potentially set a person outside of, you know, those norms that are emphasized by data science. Does this make sense? Because that's a really important point. So we started out by saying data science really looks to kind of normalize everybody, right? We try to fit a normal curve or Gaussian to like every feature that we collect about people. We collect their height, we fit a normal curve to it. We collect weight, we do a fitting of a normal curve, and we always do, you know, what is the mean and 2 standard deviations from the norm. And if we try to take a real critical stance about data science, we need to remember that our social constructions of all these terms of like who is female and who's male, who's a member of a particular race or class or disability, ends up really impacting those labels, and that sets people outside of those fitted norms or curves. And that's going to impact a lot of what data science ends up coming up with as its data science product. So it's important to remember. Okay, so we acknowledge that the forces of ableism, racism, or gender bias circulate interdependently with other biases like racism, sexism, and often in neutralized and invisible ways. So we don't really know how all these different biases might intersect, but they all tend to uphold these notions of like what is normal. And that tends to frame some of the biases of what data science ends up doing. So a really clear example of this is, I don't know if any of you learned about craniometry in the beginning of the 1900s. So the idea there was that they were going around and measuring the cranium of different people who passed away. So they had a bunch of skeletons and they were measuring heads essentially. And they were trying to convey that there's some supremacy to white people because the norm and standard deviations for that class were bigger than norms for other races and ethnicities. And this, you know, really is a way to take some data science and uphold a particular notion of what is normal. And it, by making this a data science or a data scientific way of expressing things, it can really neutralize and bring in very invisible ways very terrible biases about the notions of normalcy. So obviously the people who started out with the craniometric studies were all about trying, you know, at least initially they had the agenda of trying to uphold notions of specific supremacy to particular races. And the data science was there to kind of bolster them and neutralize that conversation by saying, oh, I'm not biased. The data is just showing me this, right? So we have to remember that we are underpinning a lot of that historical context when we're doing data science, and we have to watch out for that. So that is the critical stance we should take. And we are motivated to privilege voices of marginalized populations. So this is where I kind of depart and say, okay, well, if we are here in the responsible data science class, then I am assuming that you are motivated to give a voice to marginalized populations who may have traditionally not been acknowledged within research or within the data that drove research or building models. So we're gonna take the stance that, yeah, there has been some harm potentially done by data science, and we're trying to undo some of that. So if you are not motivated to privilege those voices, then we should have a conversation. And it doesn't have to happen right here, but please do contact me because I'm happy to have that conversation. And I do want to give voices to everybody who's in the class, but I think you'll find that many times having that assumption will end up kind of motivating the kinds of conversations that we have. So what I wanted to do today, and I'm looking at the time. So Cole, what is your thought about the QGIS intro? Should we allow people to do it on their own?
I think people will be okay with the slides on their own. this is kind of the only presentation I would say that, but most of the information in the slides is not stuff that I have to prevent. Like most of it's just a description of the different things. So I'm not worried about it if we don't get to it.
Okay. All right, but I did want to give people. Yeah, next week I'll let you take the helm.
Because I do have stuff that I will need to talk through next week.
All right, I'll shut up next week. This week, however, so we're gonna take a way that other people. So if you critique these AI blind spot cards, which from the get-go you can say, well, blind spot is already kind of a biasing term. So all of this is coming from a different group of people. So no offense taken whatsoever. However, these people were in a summer program that I also participated in, but they were in a separate group, and they created these cards to explain potential biases in data science. And of course, in a summer project, you can't possibly cover anything, but it gives a really good framing for some of those data science processes that we started talking about. And so I like using these cards because it gives people sort of like a trigger or a motivating factor to start really thinking about those data science processes and how we can be more ethical and responsible in the way we conduct data science. So this was part of the 2019 assembly program at the Berkman Klein Center. And the theme for 2019 was ethics and governance of AI. So what are these cards? And you can find them online if you wish. I think they might have changed a tiny bit since their inception. It is really, the intent is a discovery process for identifying unconscious biases and some structural inequities in AI systems. And I would say more broadly in data science, which is why we're using it here. So we kind of start out from purpose, right? Like before you go into your own data science projects, which we will do in this class, and it's 50% of your grade, we're going to identify some kind of purpose. Like you're not just going to throw a batch of data into QGIS and just hope that something comes out, right? Like you're going to identify some purpose to your project. And in particular, some of you expressed an intent of making projects that are impactful. And so we want to identify like what can we do that would present information in a responsible way and have potential, triggering people to action, potentially even, some of our stakeholders who will join us in this class. And I'll describe some of those next time. So identifying purpose is really an important part of the whole process, right? And then we move into the planning. Once we have the purpose in mind, you want to identify, well, what is the representative data that we're going to use in order to either learn a model, identify patterns in data, train some different models, use different types of strategies, both statistical strategies and otherwise, to say that you are representing something real about the world using this data set, right? So you're collecting some kind of data set and you want to ensure that it is representative and unbiased. And how we're going to do that is part of the question. Next, in the planning process, you want to plan against abusability, right? So if I'm going to say, oh yeah, I'm creating HireVue, and it's really going to make your hiring so much more efficient because you're gonna, cut down on the amount of face time that you devote to every potential candidate and employee by tenfold, and it's gonna make your HR people just so happy because they get to go home at 5 every day. Like, what are potential abuses of the system that you're presenting to them? So I think there were some ideas thrown around, and I'm really abusing HireVue here, but I think it's okay. So what are some potential abuses of a hiring system like HireVue? How can somebody take that same data product and like totally misuse it potentially?
Can you ask again?
What are some ways that somebody can kind of abuse that system of that data science outcome of like cherry picking people that are potentially good candidates to bring back for an in-person interview?
Mm. So for example, convenience sampling.
So convenience sampling, you're talking more about like what is a way to sample the data that may be like more fair or less fair, or at least that's how I understand it. How do you think that could lead to abuses?
Oh, for me, I understand convenience sampling. It's like when you pick a group of people based on just like so this person, you just go and ask them to fill out their survey, and then yeah, that's just convenience sampling for me. Rather than go out and go actually look at different group of people. Yeah.
Oh, so you're saying in the choice of representative data, you can use convenience sampling and that will result in a biased data set?
Yeah. Yeah.
Oh, okay. I'm saying more like, okay, if we decided the purpose of this project or product is to identify really good employment candidates using voice and video recognition, right? What are some ways that somebody can take the output of that and misuse it in the real world?
Looks like Raina's got her hand up.
Oh, right. Sorry, Raina, please.
Oh,
thank you.
It's okay. I'm always just worried about interrupting people. But I think that like one way for sure is it said it looked at vocabulary. So you could train your model basically to favor certain types of vocabulary. So example, like the typical speech pattern of somebody on the East Coast of the States. And that would inherently bias it against people who grew up in other areas, other countries, who don't speak English as their first language, just as a couple examples.
Right. So I agree that would create bias. I'm thinking of like me taking this system and using it for Match.com because somebody earlier said that it will create a bias for like men, right? So why don't I find men that are marriageable candidates? That would be a total abuse of that kind of data science product, right? Like somebody was trying to address one purpose and it can be completely misused in a totally different context and creating, both triggers and motivating actions that we really are undesirable. What are some other ways to demonstrate this? There was another data science product that was intended to do risk assessment among people presenting with some medical concerns. So the data inputs, and they were doing everything in their power to remove any kind of mention of race or gender from the data. So they removed all indicators of race and gender. And they just said, okay, person presented with like high blood pressure, and what should we assess as their risk, their of so-and-so age, etc. And the system learned essentially like this risk model of how likely they're going to do with both interventions and without them. And then somebody else took that outcome, and instead of motivating actions in the medical system, they used them for actuarial purposes to essentially put a number or a price on that person's medical intervention. So you can see how that's like a total abuse of what was the intended here, right? On one hand, you're trying to predict good versus bad outcomes with medical interventions. On the other, you're trying to like, hijack the price on their interventions in order to make a quick buck. And that's an unfortunate abuse of that system. So trying to really think about ways in which your system, that your data science outcome can be abused by somebody else is kind of an inverted kind of criminal mindset to try to identify, like, can somebody break into my system and actually make some bad misuse of it. But I do want to address the representative data question that Jolie brought up, and we will talk about representative data. So the way in which you sample the population in order to come up with that initial data set is ultimately very, very important, and that's what Jolie was cueing into. Also in the planning stages, you should consider privacy and security of the data, right? If this data set came out, who could be harmed by that and what are those potential risks? And then after you do all that, we should start talking about building the actual thing. So too often after purpose, people just kind of jump into building and they say, oh, we'll collect the data later and we'll think about all this stuff very late. And oftentimes that can result in some harms to some populations. So moving on to the building stage, there is discrimination by proxy. Does anybody know what that might actually mean in practice? Like, let's say I removed all indicators of gender and race from my data set. How could I still have discrimination by proxy? Yeah, Julie.
Could it be like you ignoring those kind of outliers and you normalize the data based on that, ignoring the outliers? So
yeah, so if I ignore outliers, I discriminate against people who, yeah, sit outside the norms. What about some of the, like, what are the actual features that I use to describe norms? So Reina, do you have a?
Yeah, so like zip code can be one that people like, if you had like a population map, even though you might have removed race or economic data from your data, people might be able to extrapolate anyway.
Absolutely, right. So there's a really strong correlation with health outcomes, life expectancy, educational outcomes that are associated with this specific, neighborhood that you live in. And so zip codes can really provide that kind of proxy or, proximal data that would represent those aspects that you're trying to remove from the data set. That's a really, really great example. Thank you. Going on to building, we try to think in advance, and this is something that Jolie mentioned about. This is kind of where I feel like Google Directions failed us on the explainability part, right? Like when I press that walking icon on Google Directions, I would like to have some explanation that says, hey, we're presenting to you the best data we have, but it totally excludes any real information about the walking pedestrian environment. So don't take this to mean that you can really walk there or roll there or, push a wheelchair through there. So I think on that building aspect, like as we build our systems, we want them to embed that level of explainability so that people are really clear-eyed about what it is that you're representing there. And then as we're building, a lot of times we go into optimization criteria. So I think there are certainly people in the room that are familiar with what that means. I will say, so both in data science projects and AI, we're trying to identify like, what is that closest to the norm? What is closest to the mean within those standard deviations? And we define a certain set of criteria, right? Like even in the case of like super simple criteria, like what the educational system does and says, you know, everybody to the right of the of this line goes in this direction, and everybody to the left of this line goes in that direction. They're trying to optimize for something. Potentially the optimization there is like, how many people can we take in gen ed versus non in gen ed, or, you know, whatever it is that line defines ends up optimizing for certain things. And we have to be really careful, because those optimization criteria are what drive that entire system, right? So in the case of statistical learning models, you end up actually like actively creating a cost function, which you're trying to minimize or maximize. So it's really explicit, like what it is you're optimizing for. In the case of, let's say, decision trees, those are not, it's not always really clear what you end up optimizing for, but there is some biased thought process around that. And so as we're building our systems, we want to be really clear on, you know, what is this criteria that we are driving the process towards. And so then during deployment, there is a potential generalization error, which is, I think, you know, is highly related to the representative data, right? Like if I have incredibly unrepresentative data, I'm going to take this very biased data set and generalize from it towards like the general population. That is inappropriate, and we want to be and take a critical lens to that to ensure that we're not just generalizing in inappropriate ways. And finally, as we're deploying our system, we want to provide a right to contest, right? So Jolie, when you contest what Google Directions gives you, do you feel like they gave you the right to contest what the outcome there might be? And you can comment to Google there, you know. So one time I changed their data. I was living in a different location. It was right off the Burke-Gilman Trail, and the street was actually split in two by the Burke-Gilman Trail, and they continuously put my house on the wrong side of the Burke. And so I kept having to change their data. And I commented on this in 2015, and I got an email 4 months ago to tell me that they've accepted my changes. So I think in the right to contest, we also need to put in something about timeliness, right? Because that was nearly 8 years in the making of like a tiny change to the map. So I think we have to remember all of these things. Okay, so today's objective is for you to think about some of these processes. And we have the cards are available for you to peruse. They're actually pretty, like they had really cool designers engaging in them. And each one of the cards has like a more explanation in terms of like what that step is. And what are we trying to accomplish in this step? And trying to ask certain questions that are relevant to that step that might remove some of the biases. But I don't think these cards are complete by any way. So one of the assignments for today, aside from the going through the tutorial that Cole will assign, is to kind of look at the scope and context of that card and see some of the questions that are asked there, and essentially add some more potential context or questions that you think are missing, or add a whole card that you think is completely missing here, because I can think of a couple, right, that are not even represented, but you are aware of that as being part of the data science process. So I put here the Joker card, right? Like you have some wild card that you want to add to this deck and tell us more about it. So when we're investing in a project, we want to make sure that we're invest and mitigate the effect of inequalities. So if we think about it from this lens and what we talked about today, you know, where would you add some input? Either adding to an existing card, And all of those are in the slide deck that I will share with you, but it's also available online. And what I'm asking you to do is to go to this form, and we will share this in the homework assignment, but it's tinyurl.com, non-ableist data science comment, and it's asking you to tell us if you want to add something to a card or to invent your own. Okay, so that's kind of some of the thought around what we talked about today. And it's just really an exploratory kind of assignment. So there's no right or wrong here. I'm just interested to learn more about how you're thinking about these issues and problems. And so I will leave 19 minutes for Cole. I'll stop sharing.
I probably won't get into most of the material here, but we'll give it a try. All right, so I will get a chance to talk more about my opinions and experience and viewpoints with kind of equitable data science and disability justice related topics, hopefully throughout the course, but that's something that I'm pretty involved in, so always something I love to talk about. So the software that we're going to be using in this course is called QGIS. And the purpose of this quick little presentation is just to get you acquainted with the user interface for QGIS. So a little bit of a change in topic, a very quick change in topic. But a lot of these they're easier to, this interface stuff is easier to grasp if you have QGIS actually open. And I won't ask you to open it now, but for future sessions, it is helpful to have QGIS available to you. And because it just went over my head, and I forgot to request that you download that prior to this earlier this morning, that's on me. So what is QGIS and why are we using it for this class anyway? So QGIS is an open source GIS package. And open source means that it's free to use and distribute, and license is not required. So the reason we like this software is because it's open source, and that's kind of our thing at Taskar. Another reason is that it works on kind of all systems. So whether you have a Mac computer or Windows or a Linux computer, you can use QGIS the same as somebody in another system. It also supports a lot of different data formats and a lot of functionality, including an ability to use plugins. So you can design plugins that do specific tasks. It's also actively updated. Since I created this slideshow last semester, there have been several update versions of QGIS so far. In fact, that this Kurtenbach version is no longer the most recent one. So, and it also is run by volunteers across the globe. So it really is a community project. And in this slide, which will be shared with you, I have the links to the main QGIS documentation. But we'll just go through a couple of the very basics of this, so I'll try to get through as much as I can. So if you haven't already, take some time tonight to download the most recent version of QGIS. And there are download wizards for every operating system. Then we're just briefly, I'm just going to go over the user interface. So once you download and open a new project in QGIS, you'll see something like this. And the basic things to know, just right when you open this up so you don't get lost, there are 5 major components. So at the top of the screen, you'll always end up with a menu bar. and we'll go over that in just a minute. There are also toolbars that you can turn on and off at the top to have quick access to a number of different processing tools. There are also panels. So most functions in QGIS have a panel where you can look at, for example, a browser of your files. The processing toolbox over on the right there is functions, or your layers, and rearrange your layers. A lot of this stuff is very similar between GIS software. So if you're familiar with another kind of GIS software like ArcGIS, much of this will be very similar to you. And then, of course, your map canvas where you can make changes and see what you're working on. So just a couple options available from the menu bar. So I put this in here because these are kind of just the main administrative functions that don't involve analysis in QGIS, but you have to know how to navigate the interface prior to running analysis, or you'll have some executive problems, and that's not a place where you want to be. So in the menu bar, there are options for creating and closing and exporting different project files. So that's just for file management. There's an edit option where you can get to options to edit the geography and the data sets that you have. There's also a view tab that allows you to change how you're looking at different items in the QGIS interface. And then there's also another layer tab that allows you to manage how you're bringing in and creating layers, as well as different properties for those layers and actually how to edit them as well. Some of the less important options that you'll get to know as we go along. Settings are for creating user profiles and changing things like how the interface looks. You can change fonts and icon sizes, as well as changing variable options about your settings. There's a section for plugins. So plugins are these user-written add-ons that there's 1,000 plus of. And so the plugins option allows you to find and download those plugins. Also under the plugins are the Python console. So there's an excellent scripting integration in QGIS. And you will at some point be writing Python scripts to run either plugins or processing tools in QGIS. So that's good to know where that is. And we'll get into that at some point later in the course. There are also vector and raster tabs that have to do with, if you're working with vector or raster data, you can find different plugins and major operations under those. And we'll also get to, if you're not familiar with the GIS concepts of vector and raster data, we will get to that, I think next week or the week after. And then the other tabs we'll get to know later on. This is what I was saying about user settings, is that you can change, and I only point this out because this is a feature that I use, is that I up the icon size like way higher than it is by default at the font. I make it a little bit bigger because the settings can be pretty small on a laptop, and I just add this in just to point that out. But that's what that interface looks like. Let's see, how much time do I got left here? About 10 minutes. That's all right. So we talked about the panels in QGIS. And it's hard to have this slideshow open and not be able to show you in QGIS at the same time. But that's really tricky to do with. I'm gonna look at the chat here. And I think some of you do have to run at this point, so I'll make sure that you get this slide deck. But this basically just goes over what the components of the browser panel are. The browser panel allows you to connect to different data sets, to add data sets from your computer, to run your Python scripts. So it's the system, the file navigator, basically. The processing toolbox panel was, you saw in the interface earlier. Basically what to know about this is that this is where you can run tools and scripts. So QGIS has 1,000+ analysis tools. If you add in plugins, there's 4,000 more. So it's all of them are under the processing toolbox. But you can basically use that to it's scripts, models, and processing tools. You can see kind of what the full version of that looks like on the right. Towards the bottom, those are different plugins or a variety of things that you can use to get even more functions. So these are sorted by the family of tools that they are, and you'll get more familiar with that as we get into specific tools and data and how to actually bring things in. So when you click on each of these tools, you'll get a dialog that'll ask you for certain parameters to input. And those are their parameters for how your tool will run and what it will output. The other one to know is the layer panel. And the layer panel shows you what order all your different layers of data are in, and if their visibility, how they're grouped. From layers panels, there's a layer styling panel where you can alter the symbology and the labels for all of your layers. That's more cartography specific, but it's important to know how to change how things look. So you can, let's see, under the view tab and panels, you can turn panels on and off. So like I said, the ones I usually keep on are the processing toolbox, the browser, layers, sometimes layer styling, but you can turn them on and off. You can also turn those toolbars at the top on and off. So you can change how your interface looks. Sometimes it's easy to accidentally get rid of a toolbar and you're like, oh no, where did that go? This is how you make sure that you have everything available to you. The last thing I'm gonna just touch on here quick is the what I'll call the one data button. I think I made a Lord of the Rings joke last time, but nobody thought it was funny. So, but that's what's left of that. It's called the Data Source Manager, and you can see where it is in the upper header. It's kind of these 3 pages that are right by the project tab. And basically what that does is that allows you, it's your master data control for adding in data layers and connecting to interfaces, web data sets, and databases. So it's similar to the browser in terms of that you can find, it's a file explorer, but it also has different options depending on what kind of data you want to add in or connect to. And some things you can only do via the data source manager. So that's one that we'll use a lot. And all of this, when I do examples, I'll make sure to go over again because it'll be easier, I think, once you actually see the interface. And if you haven't, I would definitely recommend just clicking around in both the documentation and the QGIS interface. Just open it up, start a new project, and just play with how you can make things look and what works best for you. So as part of the homework that we'll get out to you, is to do just that, to download the software, add in some example data sets. I have a couple linked right there. Kind of add a layer and adjust your profile preferences. So I don't think we really have a whole lot of time for questions, and I'm sorry if this was rushed, because it definitely was a little bit rushed.
Well,
But
I think once they have the slides, they can review them.
yeah, I would definitely review the slides, because fortunately this slideshow has a lot of just pictures, and this slideshow is sort of more like documentation than the other QGIS slideshows are. So
Okay, so I think the only important part at this point is to make sure everyone has access to the drive.
yeah, that's right. We'll take a couple minutes to do that. So if you that link is in the course syllabus now, isn't it?
Yeah, but I'm just gonna put it in the chat right now, so everybody who's here can try it out, make sure they're able to read all the slides. I think both of us put our decks in there already.
I think, yeah, I think so that folder basically that's where all your homework is, all the data is. I have many resource documents in there regarding tutorials and documentation and places to find data. So everything should be in there, and we'll update that with the slides as we go, and eventually the recordings too. And then, of course, if you haven't joined the Slack chat room, please do so. I think most people have at this point, but because we sometimes might post articles or additional resources and reminders in there. Plus, you can also just chat with people about data science interests, and it's good for project planning as well. So, but I think that is all I have to say.
We have 3 minutes for questions. Is anybody not seeing the shared resources?
Oh,
yeah, I see the groups. So we will allow you to form groups on your own, but first we're gonna do an exercise where people get to kind of define their own projects, just so you get to think through the process, and then we'll identify alignments across different people. In general, we have several like real world stakeholders like Seattle DOT, as well as Bellevue DOT and other people who are interested in some of what we're doing. And so hopefully your interests will align with some of those projects, because I think it's interesting to have real data and real people to work on these projects. So our process will be to sort of identify what are those projects that stakeholders have identified for us, and figure out how that aligns with your interests. I hope that explains or answers your question, Arushi.
Do they need to have some basic ideas of what they might like to do next week? Is that how we have it?
No, I think
we'll just put that off now.
Yeah, so I changed that to the assignment on the data pipeline and contribution there.
Okay.
But I will send out during this week, I will send out sort of a roster of the projects that our stakeholders are interested in, so you can get a sense of what might align with your interests. I think we will poll for that in the following week, so I have a chance to kind of explain what those projects are in a little bit more detail, or people can ask questions.
Good plan.
Anything or anyone else? Awesome. Okay. Well, thank you so much for joining. I think we have an awesome group of people here. I'm excited to keep working with you.
Yeah, looking forward to it.
And let us know if you hit any snags.
Yes, please.
Thank you.
All right. Have a nice week, everybody. We'll see you next time.